Dear college, I am Veselý from Czech Technical University, and I would like present to you my topic about measurement projectile position in dynamic projected target. And to introduction, it's good to say why we want to find shots in dynamic changing image. And the answer we can see on this, on difference of this picture, because here we have shooting range, and on the second picture is normal real environment, and we want or we need to transfer as soon condition as possible from real environment to the environment of shooting range, and it's good for better training of special security service or security forces when they training on this Davis. The essence of the Davis is projected video with real situation from real environment in front of shooter. The shooter can shot directly to the projected image, but the problem is how we can evaluate these shots. Here, for example, we could see that the men have guns, and this is situation when the shooter can shot on the picture. And how I said, the problem is how we can evaluate this shot. It's possible to make by camera and complex or difficult machine vision, but we can use some trick with lights, based on principle that we overexposed camera by these lights, and when the target is without bullet holes, the camera can see only white background without any points. But because the light beams, it's reflects from the paper to the camera, and the camera is overexposed. But when the bullet penetrates the paper, the camera can see it like a black point because the light beams passes through the paper. Yeah. But I can say that the shooter can see only projected target from data projector, because the light is in infrared spectrum. Here we can see a schema of our Davis. I use 24 voltage architecture, and the Davis is controlled by 5 buttons. The main is start Davis button, and 3 buttons for controlling of program: start, stop, and pause of program. And the last one button is for displacing of paper. I can roll paper because I would like to reduce bullet strike if I have 2 bullet holes very close together. The main component of the Davis is Raspberry Pi camera without infrared filter, and it's Sony chip with CMOS technology. And the camera predicted another components, mainly Raspberry Pi version 4. And the Raspberry is heart of Davis, or brain or Davis, and I use all CSI connectors for connect camera and display, and GPIO connectors for connecting peripherals and buttons, USB connectors for connect microphone, and services components like mouse and keyboard. Next component is step-down source for powered ventilation, motors for displacing paper roll, and a reflector. The next one is relay module that controlling motors and reflector by Raspberry Pi. Reflector we can see on the next photo is from 13 powered LED, infrared, and it's one LED have 1 watt and 400 milliamps, and I used normal data projector bank. The last one components is based for target with motor for overrolling paper, and it's motor from wipers of cars. So here is a measurement schema diagram. I would like to say that calibration is important steps because we need to connect coordinates from origin picture to picture catch by camera. And another important step is target surface scan, because we can have some holes before shooting sessions, and we should now these holes and save to the memory. And the next important step is shooting detection by microphone, and timestamp, and we save photo from camera. This is example of calibration picture, and with this bullet holes. It's for calibration. I said it. Here is a picture which can see shooter. This picture is when the infrared light is on, and this picture can see camera. And now I will processing the picture by 4 steps. The first one is reduce to size image. The second one is use Gaussian filter for reduce the noise. 3 is convert to binary picture by adaptive threshold. We can see bad settings of threshold, but here is finished process picture with only 2 black and white colors with bullet holes, and the next one is cyanide bullet holes by program. The output of program is 1 picture for 1 shot. When after the shooting session is over, the program restructuralized the video from camera and assigned coordinates with timestamp to appropriate image from origin video. And we can see here this output of shooting session. Here is the Davis that you see there with connectors for peripherals and controlling buttons, custom USB and display. And this is all measure chain, and it's all. If you have some question, you can ask me.
Thank you for your presentation. And now it's time for questions. Any questions? It could mean that your presentation was really clear.
Yes, exactly. But the audience says that yes.
We'll have one question. What about the synchronization? Because you have to synchronize what you are.
I should measure the delay of serial link, or delay causes process inside of microphone, and I want to measure this delay, and this delay I odečtu from sometime from the time then I which I choose the picture from origin video.
Okay, thank you for your answer.